Activity 9-3, friction losses. Now, this is one of the harder problems in the book, and it's made even more complicated by the fact that there's a typo. Delta P, this should be delta P2 right here, 10 psi. So that's the friction loss in this section of the pipe, and we'll get to that. The hydraulic water system shown has a storage tank on top of the hill. Water flows downhill through a pipe to fill another storage tank. A pump is used to pump the water uphill to another storage tank. There are several places where there are pressure losses due to friction. The pump adds pressure back to the system to raise the level of water in the highest tank. And they give us H1, 102 feet, H2, 140 feet, and then H3. Now, a great way to approach this problem is to think about question 1, what is the friction loss, delta P1? They want to know the friction loss down this pipe in feet of water head of the fluid flowing downhill through the pipe. Okay, so let's look at this first part of this problem 1. They want to know delta H. So we've got liquid in the first tank, and they give us H1, and H1 is 102 feet. Then we know it's 50 feet, that this tank's elevated 50 feet from the bottom of tank 2. Now I'll just draw tank 2 real quick here. Now tank 2, they tell us the height of the fluid is 140 feet. So notice that this height plus this height's 152 feet. From there to there. And the picture doesn't really do this justice, because the fact is the level of liquid in the second tank is lower than this tank. So that's the reason the water's flowing over there. If these liquid levels are the same, there'd be no flow. So we've got a pressure drop down to here, a pressure drop owing to the friction loss, and then a third pressure drop from this additional 50 feet. And then on this side, we've just got the hydrostatic pressure of 140 feet. So all the pressures right here at this point need to add up. So I've got pressure, the first one, that's 102. Pressure, that height, 50 feet, plus delta P, that gets me to here, is equal to this pressure over here, 140. The pressures are balanced. Now, this is like saying 152 plus delta P equals 140. And we can see that that's 152 minus 140 equals minus delta P. So delta P is 12 feet. Whoops. Minus 12 feet. And the other way to look at this would just be to say, well, you know what? Here it is right here. There's my 12 feet. So I didn't even need to go through all that. Okay, part 2 asks, what is the friction loss, delta P1 in PSI, of the fluid flowing downhill through the pipe? Well, that's just a unit conversion problem. So we need to go from feet of water to PSI, and we're going to use this 0.4332 number. Feet, H2O, and we said that 0.4332 psi is the same as 1 foot H2O. Those units are going to cancel out, and I'm going to be left with, what is the differential pump pressure delta P right here in feet of water head? And then they ask it, and the next question is in PSI. So if we get this one's easy to get. Okay, so what do we know is that we've got delta P. So we know it's easy to find the pressure on this side. So delta P of the pump equals And I could call this, well, let's just draw a little picture over here. So at the bottom of tank, whoops, we got H2 is 140 feet. And then over here we have some pump pressure. I'll call it P sub P. We don't know what that is, but we know it goes up a pipe. We know there's a friction loss. We know there's an elevation gain up to the bottom of the tank, and there's another hydrostatic head in the tank. So we got to add those all up. So we really don't know this guy, but we do know this guy. And delta P is just going to be P of P minus 140 from this first tank. We need to find the pressure right there, right at that pump outlet. That's what we're really after. What is that pressure right there? And well, we can just add them up. So we've got H3, and that's equal to 135 feet. And then we've got this height here of 115 feet. So P of P equals 135 plus 115. So I'm just starting to write the, let's zoom out a little bit. I'm just going to write the pressure right here. So here's my 135 comes from here. Here's the 115. Now I've got this delta P2 of 10 psi. And even though this isn't the same units, I'm just going to put it in there. I'll convert it in a little bit. 10 psi. So this plus the friction loss. And I think that's it. So all we really need to do is convert that psi to feet, and we'll have it. Here's my table on page 108. So I go down here to psi. Where did it go? Pounds per square inch. 1 psi equals, there it is, 2.309 feet of water. So the pressure on the high side of this pump is going to be equal to 135 plus 115 plus 10 times, so that's going to be 20. I'm just going to call it 23. So I've got 135 plus 115 plus 23, and I get 273. Now delta P across the pump, that's the pressure the pump has to generate to make all this work. It's going to be equal to this P sub P minus P2. We call it P2. It's because it's out of tank 2. And that's going to be equal to 273 minus 140. And I get 133 feet. So there it is. That's the hardest part of 9.3. Now when we go to convert that into differential pump pressure and PSI, that's just really straightforward. 133 feet times 0.4332 psi per foot H2O. And I didn't write feet H2O, but these are going to cancel, and I'm going to be left with units of psi. So from the pump inlet, the differential pressure between the pump inlet and the pump outlet's 57.6. So the pump outlet's 57.6 pounds higher than the pump inlet. All right, that concludes 9-3. I hope that was helpful.